Hey guys, this is Eddie the Magic Monk. Today I'm going to teach you guys how to factorize cubic polynomials. You can also just think of it as factorizing an equation where the highest power of x is 3. So in order to show you how to factorize, I'm going to show you how to expand. So let's say I have an equation y equals x minus 1 times x minus 2 times x minus 3. Right, so this is in factored form because each of these brackets is a factors, so this is what we call factored form. And now we're going to turn it into expanded form, but just before expanding it, I just want to change the notation from y to p bracket x, right? Because this is a polynomial where x is the variable. So if we expand it, then we need to draw some arrows. So let's draw some arrows. I have x times x times minus 2, and then let's draw some more arrows. And then so this then becomes x squared minus 2x minus 1x plus 2, and this becomes so x minus 3, and then minus 2x minus 1x becomes minus 3x in the middle. And then we're going to multiply by x minus 3. So again, let's draw some arrows. X squared times x squared times negative 3, negative 3x times x, and then another color. Alright, so now let's expand it all, and then I will get x cubed minus 3x squared minus 3x squared plus 9x plus 2x minus 6. So if I simplify that, I will get x cubed minus 6x squared plus 11x minus 6, right? And this is called expanded form, right? Because I have just expanded all the terms out of the brackets. And to go from factored form to expanded form, this process is called expansion. But if we want to go backwards from expanded form back into factored form, then I need to go through a process called factorisation. And in Australia we spell it with an S, but I'm guessing in America you guys use Z or Z or whatever. So anyway, now I'm going to teach you how to factorize. So going from this back into this. So how do we do that? Well, we need to be able to understand a theorem called the factor theorem. Now the factor theorem says that if a polynomial where a is the input variable is equal to 0, so the output is equal to 0, then x minus a is a factor of p bracket x. So what does that mean? Okay, what does that mean? Well, if you have a look at the example that I just gave you, okay, if I so in this example, I'm now gonna bring this example down here, right? In this example, if I let x equal to 1, okay, I'm just gonna assign the number 1 to the variable x. What happens is I will get polynomial where x is 1, so the input is 1, and that will make it, wherever x occurs, I'm going to turn it into 1, so that will be y minus 1, y minus 2, y minus 3. Alright, so instead of writing x in all these cases, I've replaced it with the value of 1. Okay, then what do I get? Y minus 1 is 0 times y minus 2. It doesn't matter what the rest equals because 0 times anything is 0. So, according to this theorem, okay, we've just tested out this theorem. If the polynomial where a is the input and the output is equal to 0, so that's what happened here, right? A is 1, and when the input is equal to 1, the output is 0, the result is 0, then x minus a is a factor of the polynomial. So according to this, x minus 1, right, because in this case a is equal to 1, is a factor of the polynomial, right? And you can see from the above equation that is definitely correct. X minus 1 is a factor of this polynomial. So therefore, basically, to factorize it, okay, we have the equation p bracket x equals x cubed minus 6x squared plus 11x minus 6. Okay, to factorize it, you need to go through a guess and check process where you're going to find a value of x where px will become 0. So you need to think about, okay, what number can I put instead of x so that the result is going to be 0. Okay, so if we try and solve this, okay, if we try and solve this, I will go 0 equals x cubed minus 6x squared plus 11x minus 6. So x cubed minus 6x squared plus 11x equals 6, right? Because I'm moving the minus 6 to the other side. Okay, now you're just going to think in your head, what number can I put in here instead of x so that the result is a 6? Okay, so naturally you're going to think of putting in the number 1, right? Because 1, let x equals 1, right? 1 cubed minus 6 times 1 squared plus 11, that will give you 1 minus 6 plus 11, which is 12 minus 6, which is 6. So yes, let x is equal to 1, right? You could also I guess that's the only way, because it'll be a bit hard to try and solve it algebraically. So guessing and checking is the best way in this case. So since x equals 1, when x is equal to 1, the polynomial of x is equal to 0. So therefore you can say that x minus 1 is a factor of p of x, right? So therefore you can rewrite the equation p of x as instead of x cubed minus 6x squared plus 11x minus 6, I can make that equal to, right, I'm going to put x minus 1 at the front, and you're just going to manually write in the second bracket what multiplied by x minus 1 will produce this equation. And since we know that in the big bracket it must be a quadratic, because x times x squared is going to give you x cubed, right? And then we don't know what the coefficient of x is going to be, so I'm just going to put in bx plus c, some sort of constant. I'm not sure what bx or c is, but I know that if I expand this out, it's going to give me the above. I just want to find out what b and c is. So what you would do from this case is you would write out the left hand side and the right hand side. So the left hand side I have, if I expand this out and so on, I will get x cubed plus bx squared plus cx minus x squared plus minus bx minus c. So I will get x cubed plus bx squared minus x squared. So that will be let me just write it out. Bx squared minus x squared plus cx minus bx minus c. So there's really no way to simplify that. So that's the right hand side. The left hand side is still x cubed minus 6x squared plus 11x minus 6. Right, and in order to figure out what b and c are, you just have to compare it. So I'm going to get all the terms where x squared is the pronumeral. Right, so then I have negative 6x squared equals bx squared minus x squared. So in order to figure out what b is, right, I'm just going to put in bx squared equals negative 6x squared plus x squared. So that's negative 5x squared equals bx squared. So b is equal to negative 5. Right, and then in order to figure out what c is, okay, in order to figure out what c is, you can see that c is the constant, and there's only one constant here, so c must equal to 6. Alright, so you can go back to this, go back to the second line and substitute b is negative 5 and c is 6 into the second line. So you will get x minus 1 x squared plus minus 5x plus 6, right? And then you can simply factorize the second part using normal quadratic factorization. So you will get x minus 1 x minus 2 and x minus 3, using simple quadratic factorization to factorize this part here. So sorry if this seems a little bit complicated, and if you don't understand my explanation, let me know and I can try make a better video.